What were the immediate challenges and success stories of 4D application at that time in the past? What was it? What were we applying it for? What were we trying? What were the solutions we were in search of?
You two are pioneering this front, so
right.
Yeah, where were you seeing those immediate applications, and then obviously we're going to go into the future of those applications.
You want me to start?
Yeah, go ahead.
So there's a lot of application in the North Sea. I think the rocks were right. You can't apply 4D everywhere. We're working towards that, but the rocks had the right compressibility, like a sponge, and it responded to fluids. Fields were on decline, and people were looking to extend production. And 4D could identify areas with bypassed oil, for example, compartments. And so it was developed really, I think its birthplace was in the North Sea, and there's a ton of applications that were developed there.
So I think the reason for that is that, first of all, it's a center for R&D in the oil and gas industry in the UK and Norway. And the business environment, I think, was conducive to 4D, as well as having the situation where these fields were at that stage of their life cycle where 4D started making a lot of sense.
Right.
And the North Sea isn't necessarily the best place in the world to acquire seismic data.
Yeah.
And you might say, well, why there first? But again, there's all these other factors that came into play. And then you started seeing 4D expanding to other basins in the world, to deep water in the Gulf of Mexico, or really spectacularly well in West Africa. I think just about every producing asset offshore West Africa probably has one or sometimes many 4D surveys acquired over them.
So here's why I was so excited about this particular talk this week. I got educated by Sue Pritchett, standing over there, and she says, here's what 4D kind of is in this time-lapse seismic. We shoot it, then we drill it, we drain it, and then we shoot it again, and we try to figure out, well, what are these anomalies that are new based on the production and the change that happen when we depressurize these reservoirs, we pump into them, we frack them, we're changing the rock that's been there for 280 million years. We change that drastically, we reshoot it, and we try to make assumptions of what those changes were. It's a fascinating idea, and we absolutely need to be doing that. But bringing it a further point is we had Steve Jumper on the show, the Dawson Geophysical CEO. We had Stoney Pollock, the end user of this new shoot that's happening in the Midland Basin. So they are shooting the highest fold to ever be done in the Midland Basin. This is the craziest shoot. It was 130,000 channels. I mean, they talk about it on the show, how intense this shoot is. And now they're going to have the highest resolution over the Midland Basin and Central Basin platform 20 years later after the original shoots were shot.
Yep.
I mean, this is 4D application to the nines in the Permian Basin, the unconventional play. Woodford, Barnett, Wolfcamp, Sprayberry, all that.
Yes, or maybe not. I mean, I think what we need to look at in terms of the future is where can we effectively apply? JP said that we don't apply 4D everywhere in the world. Now, what I will say, if you ask about how many successes, how many failures we've had, the failures have been relatively few. And that's because as an industry, I think we're pretty good at understanding the rock physics, behind 4D, and understanding the ability of seismic data to make the measurements to detect those changes that occur as a result of production.